Today we're going to go over the beginning of worksheet 10.3, the gas laws. The objective that I'm going to be going over right now is predict the effect of changing one or more of the following variables: pressure, volume, temperature, and number of moles. The first equation we're going to be discussing is the combined gas law equation. P1 times V1 over T1 equals P2 times V2 over T2. And these the numbers represent different pressures, volumes, and temperatures. A first condition and a second condition. So how would we change this equation if temperature is held constant? Well, if T1 and T2 are the same number, like let's say it's 100 Kelvin, well, you have this side divided by 100 Kelvin and this side divided by 100 Kelvin. Algebra tells us that we can just get rid of it. So imagine like you're putting something over both T1 and T2, you can write down what's left. You can actually just eliminate temperature, and our new equation is going to be P1 V1 equals P2 V2. Well, now let's think about the ramifications of that. What does that statement tell us? It's relating pressure and volume to each other. And let's think about that. Let's say you had a syringe and you decrease the volume of the syringe. We're going to decrease volume. What's going to happen to your pressure? If you decrease volume, you should be able to figure out that your pressure is going to increase. Well, let's say you weren't able to think about it and just know. We can prove it mathematically using this equation. Let's say my first pressure is 1 atm. And my volume to start off with is 2 liters. Well, my second pressure we're going to figure out, and my second volume is going to be 1 liter. So let's pretend that I'm decreasing a syringe from 2 liters to 1 liters, even though that's a really big syringe. A 2-liter syringe would be massive. So 2 liters to 1 liters. Well, this side must equal this side. 1 times 2 must equal 1 times 2. Your pressure must be equal to 2 atm. And we can now see that if this volume decreases, the pressure increases. This means that they have an inverse relationship, and this is how you represent an inverse relationship. One goes up, the other one goes down. Well, what if pressure is held constant? If pressure is held constant, we can cover up pressure in our equation and just eliminate it. If we eliminate pressure, our equation becomes V1 over T1 equals V2 over T2. Well, again, let's think about this. If you have a birthday balloon and it's quite warm, then let's say you get home and you want to do a little experiment. You stick the balloon in your freezer. What you will notice is that the volume of the balloon actually shrinks. Well, what does this look like math-wise? How can we prove this? Well, we're going to use our volume one. Let's say our first volume is 20 liters and our first temperature is 20 Kelvin. Even though this is a really, really low temperature. Let's just pretend that for the sake of ease that these are our numbers. Well, what would the volume change to if we changed the temperature to 10 Kelvin? 20 over 20 equals 1. Blank over 10 equals 1. Volume must be 10 liters. And just like I said, our temperature's going down, our volume's also going down. This means that temperature and volume are directly proportional. Temperature and volume are directly proportional. Last one, if volume is held constant, that means we can eliminate volume. P1 over T1 equals P2 over T2. Let's think about a real life example. Let's think about hairspray. There's a reason why they tell you to never heat a spray can, and that's because our volume can't change. Our volume is constant. The size of the can is never going to change. However, if our temperature goes up, then our pressure inside the can can absolutely go up, and it could even explode. Again, we can prove this mathematically. 1 atm is pressure 1 over 100 Kelvin. That's temperature 1. Again, what would happen to our pressure if we increase our temperature to 200 Kelvin? In order to keep this equal, this side equal to this side, the pressure must be 2 atm. Again, pressure and temperature are directly proportional, meaning that if our temperature goes up, then our pressure is going to go up. If our temperature went down, our pressure would then also be going down. We're going to go over the rest of this worksheet in class and do the problems on the back of this worksheet in class as well.